Here we have a SAT math problem. Okay, let's go to the question. In the figure above, right triangle RST bordered by three semicircles on each side. If the area of semicircle 1 is 8 and the area of semicircle 2 is 24, what is the length of ST? Okay, in the right triangle, we have to find the length of this line segment ST. Actually, it is an hypotenuse because it's opposite to the right angle. Okay, so in this right triangle, when I have the length of this leg SR and this length RT, I can get the length of the hypotenuse ST using the Pythagorean theorem. Okay, how do you have to get the length of these two legs SR and RT? For that, we can use the given areas of the semicircle, semicircle 1 and semicircle 2. Okay, here for semicircle 1 we have the area 8 and for semicircle 2 we have the area 24. Okay, let me assume lowercase a as the length of this leg SR and also this leg SR represents the diameter of semicircle 1. And let me assume the lowercase b as the length of this leg RT of the right triangle, and also this leg RT represents the diameter of semicircle 2. And let me say that C is the length of the hypotenuse of the triangle ST. Okay, now I have to get the values of this lowercase a and lowercase b using the given areas of semicircles. Once I get the values of a and b, I can get the value of c using Pythagorean theorem. Okay, now let me consider the area of the semicircle 1, that is 8. Okay, let me write the stuff over here. That is a1 equals to 8. That is area of semicircle 1. We know the formula to find area of a circle, that is pi r square. When I want to get the area of semicircle, I have to divide this one by 2. Since this one represents the area of semicircle 1, we can say R1 over here. That is R1 represents the radius of the semicircle 1. On the right side, we can write this 8 as it is. Okay, now let me multiply both sides of this equation by 2 to get rid of the denominator 2 on the left side. So this 2 will cancel out. I am getting pi times R1 square equals to, on the right side, 8 times 2 is 16. Okay, now let me divide both sides of this equation by pi. Then this pi will cancel out. I am getting R1 square equals to 16 over pi. Okay, now let me multiply both sides of this equation by 4. So I'll tell you the reason why we multiply both sides of this equation by 4. So in the next step, this 4 can be written as 2 square. 2 square times R1 square. On the right side, we can multiply this 16 and 4. 16 times 4 is 64 divided by pi. Okay, here two terms are multiplied with the same exponent 2. Whenever two terms are multiplied with the same exponent, what we can do is we can write the exponent in common. That is, we have to multiply the bases. Then we get 2 times R1 the whole square equals to 64 divided by pi. Okay, we know that R1 is the radius of semicircle 1. It is multiplied by 2. Then this 2R1 represents the diameter of the semicircle 1. So actually the diameter of the semicircle 1 is just A. So now we can replace this diameter 2 times R1 by A. Then we get A and we can take this exponent 2 as it is. That is A square equals to 64 divided by pi. So to get to R1, that is to get the diameter, I just multiplied both sides of the equation over here by 4. Okay, now we have to do the same process for the area of semicircle 2, that is given over here 24. Okay, let me write the stuff over here. A2 equals to 24, that is area of semicircle 2. Then we can write pi R2 square divided by 2. So since we have the area of the semicircle, I just divided the area of the circle by 2. And this R2 represents the radius of the semicircle, which is equal to 24. Now let me multiply both sides by 2. When I do so, this 2 will cancel out. Then I'm getting pi R2 square equals to 48. Now let me divide both sides of this equation by pi. This pi will cancel out. Then I'm getting R2 square equals to 48 divided by pi. Now let me multiply both sides of this equation by 4. When I do so, and also this 4 can be written as 2 square times R2 square, and 48 times 4 is 190 divided by pi. Now we can write this as 2R2 the whole square equals to 192 divided by pi. Okay, so R2 represents the radius of semicircle 2. When it is multiplied by 2, this 2R2 represents the diameter of semicircle 2. We know that this lowercase b represents the diameter of semicircle 2. So we can plug in b for this 2R2, then we get b square on the left side. On the right side, we have 192 divided by pi. Okay, now in this right triangle, I got the squares of the two legs, a square and b square. Okay, now we can use the Pythagorean theorem in this right triangle SRT. So that is a square positive b square equals to c square. That is the sum of the squares of two legs of a right triangle equals to square of the hypotenuse. Already we got the value of a square, that is 64 divided by pi. We can plug in this for a square, and for b square we know that 192 by pi equals to c square. Okay, here we are adding two fractions with the same denominator pi, so we can take pi as a common denominator. We can add the numerator 64 positive 192 equals to c square. When I add 64 and 192, I am getting 256 divided by pi equals to c square. My aim is to get the value of c, so for that we have to get up the square over here. To get up the square, I am taking square root on both sides. Now the square root and square will cancel out, and on the left side we can take the square root for numerator and denominator separately. Then we have square root of 256 by square root of pi equals to c. Okay, square root of 256 is just 16 divided by square root of pi equals to c. Actually, this c represents the length of the hypotenuse, that is st. Okay, now I got the length of the line segment st, so it is equal to 16 divided by square root of pi. We find this 16 divided by square root of pi in answer choice A. The correct answer choice for this question is A.